Okay, and now we have exercise 16.1 question 3. Okay, basically, right, I just skip forward first. Basically, they want us to find dy dx, so instead of using quotient rule, I express it this way so that we can use the product rule. So straight away I find that dy dx is v du dx, okay, which is 2 over x squared minus 4, okay, plus u dv dx. So in this case it is minus 2x over x squared minus 4 square. Okay, and that is part 1. I think you should be quite experts in this already. So we just quickly go to part 2. Find the x coordinate of each stationary point. So we know that a stationary point dy dx is equals to 0. So I have is 2x squared minus 4 minus, okay, this part I multiply in the 2x, I get 4x squared minus 10x over x squared minus 4 squared is equals to 0. To solve this, I multiply throughout by x squared minus 4 squared. This one here. Okay, so what I achieve here is 2x squared minus 4 minus 4x squared minus 10x is equals to 0. So down here I get 2x squared minus 8 minus 4x squared plus 10x is equals to 0. I get negative 2x squared plus 10x minus 8 is equals to 0. So what I do now here, divide throughout by negative 2, I get x squared minus 5x plus 4 is equals to 0. To solve quickly, I just factorize. I get x equals to 4 or x equals to 1. Notice that they want you to find only the x coordinate, okay, so please do not bother finding the y coordinates. And I am done with question 3. Now I'm going to show you question 6. Okay, for question 6, right, I'm going to just show you 6a. Okay, 6a, they will... Okay, let me show you question 5 first, sorry. So I show you question 5 first before I do 6a. Okay, question 5, what we have is y equals to x minus 5 multiplied to 7 plus x to the power of half. Very quickly, this one, okay, we apply product rule. I just show you the final answer. I don't want to pamper you too much, okay. In the end, if you do the product rule correctly, okay, first, okay, then I'll just show you the whole product rule. Okay, u equals to x minus 5, du dx equals to 1. V equals to 7 plus x to the power of half. Okay, differentiating v with respect to x, you get half 7 plus x to the power of negative half equals to 1 over 2 square root of 7 plus x. Okay, so we get dy dx is equals to v times du dx plus times du dx is 1, sorry, plus u, okay, times dv dx. So you get 2 over square root of 7 plus x. So you simplify is square root of 7 plus x minus 5 over 2 square root of 7 plus x. And this is the dy dx for 5 part 1. Now, they ask you to find the coordinates of the stationary point. To do this, as we now know, we get dy dx is equals to 0. So we get square root of 7 plus x minus 5 over 2 square root of 7 plus x is equals to 0. Simplest way of solving this equation will be multiplying throughout by 2 square root of 7 plus x. So this one, 2 times square root of 7 plus x, square root 7 plus x, it gives you 7 plus x. This one plus x minus 5 is equals to 0. So we expand the brackets. So we get 3x plus 9 is equals to 0. X is equals to negative 3. Now, we have to find the coordinates. So to find my y value, okay, I look back way down here at this original equation, I sub it in, so I get minus 3 minus 5, 7 minus 3 to the power of half. So we get negative 8 times 2, y is equals to negative 16. So my stationary point coordinates are basically negative 3, negative 16. Okay, then part 3. Part 3 is something new, so please take note of part 3. Let me start this on a new piece of paper. Part 3, they ask for something that is called the sine of dy dx. Okay, so basically, right, when we want the sine of dy dx, first I set up the x, okay, then the coordinates of the x point is negative 3, okay, then we want sine of dy dx. Okay, so basically, right, it works like this. We start at negative 3, then we go for something that is slightly larger than negative 3, and we go for slightly something smaller than negative 3. Okay, so what you do here is this. So if you see a number line, this is negative 3. Something slightly larger than negative 3 is negative 2.99. Something slightly smaller, negative 3 minus slightly something smaller, okay, will be maybe negative 3.01. Okay, just take this negative 3.01 and negative 2.99, okay, you key it into the dy dx. dy dx is down here. Okay, you're just going to try with a calculator, going to key these two values, negative 3.01, negative 2.99, into this whole function for dy dx. You will notice that for negative 3.01, okay, you notice that you get a negative number. This will be a negative value. Negative value, right, means that the gradient will be like this. It's going downwards. Similarly, if you were to key negative 3, okay, which is the turning point itself, you'll notice that you will get the value of 0. So it's a flat line like this. For negative 2.99, you key in down here into the dy dx, you notice that you will get a positive value, which means that the gradient should look something like this. So what this means is that if you were to sketch the turning point, okay, at the turning point, it's going to look something like this. Okay, so therefore the nature of the point when you have something like this, is this a maximum point or a minimum point? Okay, think for a while. From what we already know, when it goes down like this, what we have is that the nature is that of a minimum point. And that is that for 5 part 3. Okay, now I will do question 6 for you. Question 6a. First, we have to find the second derivative, okay, to determine the nature of each stationary point. So we start with y is equals to x cubed minus 12x. Okay, 6a will illustrate to you. Just now I used the sign to determine, okay, sine of dy dx to determine if the point is a maximum point or minimum point. Now I'll teach you something new, which is the use of the second derivative. So first, I differentiate with respect to x. I get 3x squared minus 12. Okay, then now to find the stationary points, I get dy dx is equals to 0. 3x squared minus 12 is equals to 0. Quickly solving, 3x squared is equals to 12. Okay, x equals to 2 or negative 2. Then you sub back into your y values, okay, into your original equation down here. You will find that your y value is equals to this one will be 16, and this is negative 16. So I write coordinates are 2, negative 16, or negative 2, 16, like this. Okay, that is for the first part where they ask you to find the stationary points. Now we have something new called the second derivative. Okay, before I even finish this question, I want to talk a bit about the second derivative. Okay, it is found that if for the second derivative for a value of x, if the second derivative is lesser than 0, okay, what this indicates is that for that point it is a maximum point. Similarly, if for the second derivative you find that it's greater than 0, what you actually get it is a minimum point. So please note this down. These are your notes for this part here. Okay, so now bear in mind x equals to 2 and x equals to negative 2. From here I find my second derivative. So dy dx is equals to 3x squared minus 12. So if I find my second derivative, I get 6x. Okay, so now I test for both points when second derivative x is equals to 2. I get 6 times 2 is equals to 12. 12 is greater than 0. As we learned from the previous page, this means that this is a minimum point. So therefore, I know that 2 negative 16, okay, is a minimum point. So instead of actually testing like what we do just now to find the different signs, we can just do this using the second derivative. Similarly, when I let x equals to negative 2, 6 times negative 2 is negative 12. Is smaller than 0. This indicates that this is a maximum point. So therefore I know that negative 2, 16 is a maximum point. And that's that, okay, for my examples from exercise 16.1. Thank you for watching.